So we're just going to get 6.3 started today. We'll get through A, and then, because A is pretty short, and then we'll do part objective B today. Okay, so let's first just talk about the identity matrix. So the identity matrix is the matrix when you multiply, you get the same thing. So like with real numbers, 1 is the identity. You can do 5 times 1 and get 5. So I want to know what I is, and we've talked about it already a little bit. So when I multiply I by A, I still get matrix A. Okay, so to work this out, I'm just going to multiply A times I. Okay, so A is a 2 by 2 matrix. I is a 2 by 2 matrix. And so then I know the result will also be a 2 by 2 matrix. Okay. So I'm going to put the shell, I'm going to write the shell out for multiplying A times I. So I know it's going to be a 2 by 2, so I want 2 rows and 2 columns. And then after I multiply, I get A again. Okay. So let's go through the multiplication. If I want the first entry, the first row and first column, then I'm going to do 3 times A plus negative 5 times C. Then I will do the first row, first column, or second column, first row, second column. That's 3B plus negative 5 times B. Then I'll move to the second row, first column. That's 2A plus 1C. And then finally, second row, second column. That's 2B plus 1D. Okay, well, to find the value of my variables, then I can set up these equations. I know that 3A minus 5C has to equal 3. Because after I multiply, that's what I'm getting. So when I would simplify, I would get 3. Okay, and then I know then that 3B minus 5D should equal negative 5. Okay. And then 2A plus C should equal what? 2. And 2B plus D should equal 1. Okay. So I have 4 equations, and each equation has 2 variables. So I'm going to have to set up 2 systems of equations. So the first system, let's say I'm going to take this first equation, 3A minus 5C equals 3. What other equation should I pair with that? Yeah, the 2A plus C equals 2, because those have the same variables. So just over here to the side, I'm going to write 3A minus 5C equals 3. and 2a plus c equals 2. Okay, so I want to solve that system. Okay. So I'm going to multiply the second equation by 5, so I'll use elimination. I'm going to multiply the second equation by 5, and I can eliminate c. Okay, so that's 10a plus 5c equals 10. And I'll add down. So 13a equals 13. So a equals 1. Okay, go back up and plug that in. I'll plug it into the top one. So that's 3 times 1 minus 5c equals 3. Okay, subtract 3, and I get c equals 0. Okay, so far I have a and c. Go back to your 4 equations that we wrote, and let's do the same thing, but this time with the equations that have b and d. So that's 3b minus 5d equals negative 5, and 2b plus d equals 1. So I'm solving this system again. I think I can do the same thing as I did on the first system, multiply the second equation by positive 5. So that's 10b plus 5d equals 5. So 13b equals 0. So b is 0. Okay, and then plug that back in. So 3 times 0 minus 5 times d equals negative 5. So negative 5d equals negative 5, which means d is 1. Okay, so there's my other 2 entries. So that tells me that so A, B, C, D, so 1, 0, 0, 1. So this is the identity for a 2 by 2 matrix. That's basically what we proved. And we've talked about that already, but this is why we get 1, 0, 0, 1. We wanted to know what we had to multiply A to get A. So we did that multiplication backwards and solved and got 1, 0, 0, 1. Okay, and identity for a 3 by 3. 1, 0, 0, 0, 1, 0, 0, 0, 1. So your identity matrices have 1s in the diagonal and then 0s everywhere else. Okay. So we want to use that, use identities to start talking about inverses. Everybody okay with what's up here? catch everything. All right, so inverses are what you multiply by a matrix to go back to the identity. So if A times B equals I, then A is the inverse of B or B is the inverse of A. Okay, you don't have to tell which one, but it's okay. We have to know that only square matrices have an inverse. So square matrices means the rows and columns are the same. So 2 by 2, 3 by 3, 4 by 4, those are square matrices. So let's think about A and B as real numbers. So let's say A is 3, and I for real numbers is 1. So what would I multiply 3 by to get 1? What would I multiply 3 by to get the identity? 1/3. So 1/3 is the inverse of 3. And if you have 7, 1/7 is the inverse of 7. It's what you multiply it by to go back to 1, back to the identity. So we're going to do that, find the inverse of A now. Okay, so, and we use that, this little notation with the -1, A to the -1, that means inverse. So I'm going to find the inverse of A, just like I did when I was trying to find the identity. So just like I did in the previous problem. So first thing I'll say is let's let B, matrix B, be A, B, C, B. So then I can solve for each entry. Okay, so I'll be doing 2 times 5, -3, 4 times A, B, C, D. And that will give me the identity, 1, 0, 0, 1. Again, these are all 2 by 2s, so when you set up your shell for the multiplication, that's going to be a 2 by 2. When you multiply those, so that's the shell for the multiplying, and then when I simplify, I'm supposed to get 1, 0, 0, 1. Okay, so let me get you started. So you're going to do the first row, first column. So 2 times A plus 5 times C. And then we need to do the first row, second column. So 2 times B plus 5 times D. Okay, try to fill out those that bottom row there. Yeah. Are we good there? Yeah, okay. Okay, so then the second row, first column should be -3A plus 4C. And then second row, second column should be -3B plus 4C. Okay. So when those simplify, they should simplify to 1, 0, 0, 1. So let's write out our 4 equations. 2a plus 5c should equal 1. 2b plus 5d should equal 0. And I'm going to go ahead and separate these so I can put the equations with the same variables together. Negative 3a plus 4c equals 0. And negative 3b plus 4d equals 1. Okay, so we're going to do elimination, and we'll have to multiply both equations. So if I'm looking at A and C, that system, I will multiply the top one by 2 and the bottom one by 3. The other way around. Thank you. I'll multiply the top one by 3 and the bottom one by 2. So that's 6a. Okay, 6a plus 15c equals 3. Negative 6a plus 8c equals 0. So I get 23c equals 3. So c equals 3 over 23. That's not a very nice number, but think about it. Like, the inverse of 3 is 1/3. So it makes sense that we have fractions here. Okay, so just because you have a fraction doesn't mean that it's wrong. So I'm going to go back up to the top equation and plug that in. So 2a plus 5 times 3 over 23 equals 1. I'll help you with these calculations. So that's 15 over 23. Subtract 1 minus 15 over 23 is 8 over 23. Divide by 2 and you get 4 over 23. So there's A and C. Okay, do the same thing for this system for B and D. So I'm going to do the same multiplying. I'll multiply the top one by 3 and the bottom one by 2. Oh, no, go for it. All right, so then I get 6b plus 15d equals 0. Negative 6b plus 8d equals 2. Okay? So 23b equals 2. So this times d is 2 over 23. It's a bit silly, like when you get the same denominator there, even though they're not nice numbers, but that should kind of reassure you that you're on the right track. So not very pretty numbers. And they won't always all have the same denominator because sometimes when you reduce, it can make them smaller. Okay, so plug d back in. So 2b plus 5 times 2 over 23 equals 0. So 2b plus 10 over 23. Subtract and divide, so again, I'll help you with this real quick. So negative 10 over 23, divide by 2, that's going to be negative 5 over 23. Okay, so there's your 4 entries. So let's write them back in matrix form then. So B, matrix B, write it in order A, B, C, D. So A is 4 over 23, B is negative 5 over 23, C is 3 over 23, and D is 2 over 23. And that is A inverse. So how can I know that that's correct? Because you're not going to get nice numbers. How can we know that that's correct? Yeah, multiply B by which one? A, and what should you get? You should get I, the identity, 1, 0, 0, 1. So when you multiply B times A, since they're inverses, that's going to give you 1. So that is